In this episode, we're going to build a beginner-friendly way to spot threats, vulnerabilities, and real-world exploits early, without turning this into a deep technical hacking lesson. For the Certified Information Privacy Technologist, CIPT, exam, you don't need to know how to run tools or write exploits, but you do need to recognize the patterns that lead to privacy harm so you can ask the right questions and advocate for the right controls. Many new learners think of threats as scary attackers and vulnerabilities as technical bugs, and while that is partly true, privacy problems often come from a wider set of patterns: misconfigurations, excessive data collection, overbroad access, insecure defaults, and systems that make it easy to misuse data. Spotting issues early means learning to look at data flows and user expectations, and then noticing where those flows could be exposed, altered, or misused. The benefit of doing this early is that prevention is cheaper than cleanup, and strong privacy design often depends on catching problems during planning rather than after deployment. By the end, you should be able to narrate how threats and vulnerabilities relate to privacy, what common exploit patterns look like in plain language, and how to reason about risk before a bad event happens. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at Cyber.Author.me in the Bare Metal Study Guide series. To get oriented, let's define these three terms in a practical way that fits privacy technology work. A threat is something that could cause harm, such as a malicious actor, an insider with bad intent, a careless process, or even a design choice that creates predictable misuse. A vulnerability is a weakness that makes it easier for a threat to cause harm, such as weak authentication, missing access control checks, insecure storage, or unclear authorization boundaries. An exploit is the actual method used to take advantage of a vulnerability, such as guessing credentials, abusing a misconfigured permission, or pulling data through an interface that exposes more than intended. For privacy, harm is often tied to exposure, misuse, or loss of control over personal data. So the lens is not only whether something is secure, but whether personal data could be accessed or used in ways that violate expectations and obligations. That means you can think of threats as who or what might cause a privacy failure, vulnerabilities as the openings that make failure possible, and exploits as the paths that turn openings into real impact. This framing is useful because it keeps you focused on outcomes and not on the glamour of technical details. A high-yield way to spot issues early is to start with what the system is promising and what the system is doing, because mismatch is a signal of risk. If a system promises limited use, but the architecture enables broad use, that gap is a vulnerability in governance and design. If a system promises user control, but the data flow does not carry preference signals to downstream processing, that gap is a vulnerability in enforcement. If a system promises limited retention, but logs and backups keep data indefinitely, that gap is a vulnerability in lifecycle management. These are not always bugs in the traditional sense, but they create predictable pathways for harm, which is what vulnerabilities really represent. Exam scenarios often describe a feature change or data use expansion and then ask what risk exists or what control is needed, and noticing mismatch quickly gives you a strong answer direction. Early spotting is about seeing structural risk, not just looking for a single broken line of code. Now let's connect this to data flows, because data flow thinking is one of your best early detection tools. When data enters a system, moves through services, gets stored, is accessed by people, is exported, and is shared with vendors, each transition point is a place where threats can act and vulnerabilities can exist. For example, data collection points can be exploited by collecting more than intended, collecting from the wrong person, or collecting without proper notice and choice. Storage points can be exploited by weak access controls, poor segmentation, or misconfigured permissions. Access points can be exploited by over-permissive roles, shared accounts, or lack of logging and monitoring. Export and sharing points can be exploited by interfaces that leak too much data, by insecure transfer, or by vendors that use data beyond scope. If you can trace the flow, you can ask what could go wrong at each step, which is exactly the mindset you need for spotting threats early. On the exam, Questions often center on these transition points, because that is where control failures tend to show up. One common real-world exploit pattern is unauthorized access through weak authentication or credential abuse, and you don't need to know hacking to understand it. If users or employees reuse passwords, if multi-factor is absent, or if privileged accounts are not protected, attackers can gain access and then browse or export data. Another pattern is session hijacking or token misuse, where a valid session token is stolen or misused to access data without needing to guess a password. Another pattern is brute force attempts against weak login protections, especially when rate limits and monitoring are absent. From a privacy perspective, the issue is not only that someone got in, but that once inside they might access personal data far beyond what any single account should be able to reach. That is why least privilege and segmentation matter, and why logging and anomaly detection matter, because they help you spot abuse early. The exam may not ask you to identify the exact technique, but it may ask what control best reduces the risk, and controls that strengthen authentication and limit lateral access are often key. Another major exploit pattern is misconfiguration, which is arguably more common than sophisticated exploitation in everyday incidents. Misconfiguration can include storage that is exposed to the internet, overly broad access permissions, debug settings left on, or interfaces that return more data than intended. The tricky part is that misconfigurations are often created by normal work, like a developer trying to fix an issue quickly or an administrator copying a template without adjusting permissions. From a privacy viewpoint, misconfiguration is dangerous because it can expose large volumes of personal data without any targeted attack, meaning exposure can happen simply because the data is reachable. Early spotting means building checks into change management, using safe defaults, and reviewing permissions with a skeptical mindset. Exam scenarios often describe a configuration error and ask what you should do next, and the best answer usually includes immediate containment plus a process improvement that prevents recurrence. Recognizing misconfiguration as a leading cause of privacy incidents helps you prioritize practical controls. Excessive access is another vulnerability class that shows up repeatedly in privacy harms, and it is often an internal risk, not only an external attacker risk. If too many employees can access personal data, then accidental exposure becomes more likely, misuse becomes harder to detect, and accountability becomes fuzzy. Overly broad access can come from roles that are too permissive, from lack of segregation between environments, or from shared credentials. It can also come from systems that do not enforce access control consistently across services, meaning one interface is protected while another bypasses checks. Early spotting involves reviewing who can access what, why they need it, and whether access is logged and reviewed. It also involves designing systems so that sensitive data is separated and access is granted only when needed. The exam can test this by presenting a scenario where an employee accessed data for an inappropriate reason and asking what control would best reduce this risk, and least privilege plus monitoring is often the heart of the answer. Data leakage through interfaces is a classic exploit pattern that often feels invisible to beginners because it can happen without dramatic signs. An application might expose personal data through an application programming interface that returns full profiles when only a subset is needed. A search feature might allow enumeration, meaning an attacker can systematically query and retrieve data by trying many inputs. Error messages might reveal personal data or internal identifiers. Logs might capture sensitive inputs, like passwords or government identifiers, because someone enabled verbose logging during debugging. Early spotting means asking what data a feature truly needs to function, and then ensuring the output is minimized and appropriately protected. It also means thinking about abuse cases, such as what happens if someone repeatedly calls a feature or tries to extract data at scale. On the exam, questions often describe a feature that exposes too much information, and the best answer usually involves tightening outputs, enforcing authorization checks, and limiting abusive patterns. Another privacy-relevant vulnerability is insecure data handling at rest and in transit, because data can be exposed during storage or movement. Encryption is an important control, but beginners should understand its limits and its purpose. Encryption helps protect data if storage is accessed improperly or if traffic is intercepted, But encryption does not prevent misuse by authorized users, and it does not fix over-collection or inappropriate sharing. Early spotting means ensuring that sensitive data is protected during transfer and storage, while also ensuring that access is controlled and monitored so encryption keys do not become a single point of failure. It also means understanding where sensitive data ends up, such as in backups, replicas, or analytics stores, because those copies must also be protected. Exam questions may tempt you to pick encryption as the answer to everything, but the best choice depends on whether the scenario is about exposure during transfer, exposure due to access control, or misuse due to purpose creep. Spotting which category you are in is how you choose correctly. Real-world exploitation is not always driven by outsiders, and privacy technologists must be alert to insider and partner risks. An insider could misuse access intentionally or could expose data accidentally by exporting it to the wrong place, emailing the wrong attachment, or using unapproved tools. A partner could receive data and then mishandle it, reuse it beyond scope, or store it longer than agreed. These risks are reduced through least privilege, monitoring, training, and strong third-party controls, but early spotting comes from understanding where data is accessible and where it can leave controlled environments. For example, if a system makes it easy to export full datasets without approvals, that is a vulnerability even if nobody has exploited it yet. If a vendor integration sends more data than needed, that is a vulnerability even if the vendor is trustworthy, because the exposure surface is larger than necessary. The exam can test this by describing a partner misuse scenario and asking what process or control reduces the risk, and answers that include scoped sharing and monitoring tend to be strong. To spot threats and vulnerabilities early, you also need to understand the difference between a weakness that is theoretical and one that is likely to be exploited. Likelihood is influenced by exposure, ease of exploitation, and the value of the data. A sensitive dataset exposed through an internet-facing interface is high likelihood, while a niche internal system behind multiple controls may be lower likelihood, though still important. Ease matters because simple exploits are used more often than complex ones, which is why misconfigurations and credential abuse are so common. Value matters because datasets that can support identity theft, fraud, or targeted harassment are attractive targets. A beginner-friendly habit is to ask how exposed the weakness is, how easy it would be to exploit, and what the impact could be. This habit supports risk prioritization, which is essential in real operations and is often tested indirectly on the exam through best next step questions. Early spotting is not just noticing weaknesses, it is noticing which weaknesses matter most. A practical way to make all of this usable is to create an early warning mindset that is built around a few recurring questions you can apply to any new feature or data flow. You ask what personal data is involved, where it enters, where it travels, where it is stored, who can access it, and where it can leave. You ask what controls enforce least privilege and whether those controls are consistent across all paths. You ask whether outputs are minimized and whether interfaces can be abused at scale. You ask whether retention and deletion are enforceable across primary stores, logs, and vendor systems. You ask how monitoring would detect misuse and what would trigger incident response. You also ask whether user notices and choices align with actual behavior, because mismatch is a signal of a governance vulnerability. This is the kind of thinking that helps you answer exam questions without needing to memorize tool-specific details, because it is about patterns and consequences. When you learn to spot threats, vulnerabilities, and real-world exploits early, you become better at preventing privacy harm. And you also become better at choosing correct answers on the CIPT exam, because you can see how a scenario could go wrong and what control would actually reduce that risk. The exam rewards pattern recognition, such as recognizing that misconfiguration and overbroad access are common causes of exposure, or recognizing that choice signals must propagate to prevent misuse. It also rewards understanding that not every control solves every problem, so the right response depends on the type of vulnerability and the nature of the threat. If you anchor your reasoning on data flows, exposure points, and likely exploit patterns, you can identify risks earlier, respond more effectively, and advocate for design choices that reduce harm before it happens. That is the real skill here, seeing problems while they are still cheap to fix, and translating that foresight into practical, privacy-respecting decisions.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.